Alright, welcome 6th graders to a Chapter 9 review about rocks and soils. We learned a lot about mechanical and chemical weathering, and we talked about soil conservation. So I'm just going to review these topics with you throughout this video. So weathering is just the breakdown of rocks into sediment, or smaller pieces, by physical means such as it can be due to wind, water, or gravity. Those are just examples of ways that weathering happens. So these different forces are acting to break down rocks. So there are two different types of weathering. The first one is mechanical weathering. And mechanical weathering is, it involves a physical force or breakdown. Think like a mechanic, right? You're doing something kind of with your hands. It's a physical action that's happening to the rocks. There's several different types. The first one is ice wedging. So in ice wedging, you have a big rock, and it might have a little bit of a crack in it. And during the day, water can get into that crack. And then at night, right, so that's at day. At night, here's our same rock. That crack now is going to expand a little bit because water expands when it freezes by 9%. And so because of that expansion, it's going to eventually cause this rock to, at night as the water expands, cause the crack to grow a little bit, and then during the day, that ice melts, so some more water can fill it, and then that rock is going to eventually expand more and more. This crack is going to expand more and more, and it can actually cause your rock to break in two. Okay? Just because of this ice wedging it apart. It's pulling these two rocks apart, or it's pushing the two rocks apart. Alright, the second type of mechanical weathering is abrasion. And if you think about someone with if you see someone has an abrasive personality, that means they're kind of rubbing on you the wrong way. If someone's abrasive with their words, they're just really rough with their words. So abrasion, think about rocks rubbing against one another. And it's that rubbing against, that rubbing against action that really causes the rocks to rough up against one another. I'll show you a picture of what this might look like. We saw these pictures in class. We said, okay, here's this rock, right? And see how it has rough edges? So I'm going to take and put this picture down here. And we can compare those rough edges, like a rough rock, to then one that's been abrasively weathered, like these rocks here. See how their edges are all round and smooth? So these rocks right here, they're smooth. Rocks that have undergone abrasion are going to be rounded out smooth. Think like a river rock. If you recall, I talked about these particular rocks. I got them in a creek when I worked at camp, and so those are special rocks to me. They're from Kidder Creek, one of my favorite places, and so it's just a way to remember, right? I got some rocks from the top of a mountain that were really sharp and jagged, but after sharp and jagged rocks rub against each other, their edges kind of smooth out, okay? They're rubbing against one another, their edges smooth out. We can also see this with the lab that we did in class when we shook the sandstone, right? As we shook the sandstone in a jar of water, we had all our little rocks in a jar of water, and as we shook it back and forth, the rocks rubbed against each other, right? That was abrasion. So we mechanically weathered these rocks. If you see the jagged edges here, right, all that looks really rough, it begins to get a little bit smoother here after 100 shakes. By about 200 shakes, they're much smoother. And you can just see, even in this picture, they just get smoother and smoother. And the pieces are getting smaller as they go too. The more they shook these rocks, the more the sand was being grated off of them. The water was filling with sand. Remember, it turned from a nice, we started with blue water, but by the end, our water was definitely not blue. It was more this yellow tan because of the sandstone rocks were losing the sand as they rubbed against one another. That rubbed off during abrasion. And then our third type of mechanical weathering is exfoliation. And exfoliation, remember we described it and we compared it to exfoliating your skin. If you're exfoliating your skin, you're like peeling off that upper layer of skin, removing dead skin cells. So we described that as similar to exfoliation of rocks. Exfoliation of rocks means it's when a rock layer just peels away. And this is due to the removal of pressure. So if you have a rock, right, and it has kind of layers within it, if this top layer is weathered by some sort of physical or chemical means, and then it is eroded away, so that top layer is eroded away, means it's been transported off, right? So your top layer is eroded. Suddenly all this pressure, all this weight that was on this second layer is now gone. So now suddenly all this pressure is gone, and that just causes this top layer to separate. So our top layer now becomes, it might break off in little chunks. You might end up with kind of its own little rock to the side. Basically, it's just you have this little shards of rock that kind of separate. Right? If you have a big rock, you end up with, if over here there used to be pressure pushing down right here. After that pressure is removed by the erosion of the top layer, then suddenly this little rock right here might become its own separate rock layer. You might see in the rock just the different shards or sheets. It kind of looks like the rock peels off in a sheet. for example, a picture of this we looked at in class. This is from the USGS, U.S. Geological Survey. You can see in this picture the kind of shards, the layers of the rock. And some of them have clearly been eroded and carried away as a result, and you can kind of see the layers. So this is a picture of exfoliation. All right, our next type of mechanical weathering is plant growth. And plant growth is what it sounds like. It's weathering of rocks due to a plant's roots growing. Roots of a plant are very strong. You wouldn't think it to look at a plant, but for example, a tree has extremely strong roots. Even smaller plants have really strong roots. And so as those roots go into the ground, they can break down and erode rocks. Right, you have rocks inside the ground, and they can actually break and move and scrape against rocks, and as a result, rocks can be weathered. So plants get super strong roots. Those roots can cause the breakdown of rocks. Splitting rocks due to root growth. All right, our fifth type of mechanical weathering is animal actions. This one's rather self-explanatory as well. Rocks can be weathered because of, say, earthworms in the ground. You have a little worm. Or if you have a burrowing animal, so think like a rabbit, worms, rabbits, any sort of animal that is insects. Any animal that is inside the ground can have a weathering, a physical weathering action on a rock. They can kind of burrow through rocks, they can scrape the rocks. As we get into chemical weathering now, we're going to be talking about how the fluids that are excreted from, say, a worm can weather a rock chemically as well as like the physical rubbing of a worm against two rocks. All right, so now we're going to talk about chemical weathering. It's still weathering, so it's still the breakdown of rocks, but chemical weathering is a process by which rocks break down as a result of chemical reactions. So the rocks are breaking down. That's just the definition of weathering. When we say chemical weathering, it means due to chemical reactions. And you won't really be learning about how chemical reactions work until you get to 8th grade. I'll spend a good chunk of time in 8th grade talking about chemical reactions. But you guys are familiar with the concept of chemicals, and that some chemicals, you don't want to touch with your hands because they can hurt your skin, or they can hurt your eyes. So this is just a chemical reaction. Think like baking soda and vinegar. When you put them together, you get this bubbly, fizzy reaction. And so that's a chemical reaction, putting baking soda and vinegar together. So chemical weathering, you're putting two different things together So 1 plus 2, you get something new, some new substance, and that can have a reaction. If you have, say, some sort of chemical with the chemical in the rocks, you get the breakdown of rocks. Oops. Chemical reaction. All right. So for example, you could have water dissolved chemicals. That make up a rock, so like granite can be broken down this way. You can have acid rain, acid precipitation. An acid rain is, for example, due to volcanoes or pollution. Putting chemicals in the air, it causes really rapid weathering. And then our next type, it still has to do with water. So we've talked about water dissolving chemicals. And breaking down the dissolving the chemicals and breaking down the rock that way. For example, with granite or acid precipitation, the volcanoes, pollution. They put acid or acid gets into the water vapor in the air, and that collects as precipitation in the cloud, or as water vapor in the clouds, and then that comes down in the form of precipitation. That causes really rapid weathering. You also have groundwater. That can contain like carbonic or sulfuric acid. It's really strong acids. That they erode, say, limestone from cavern. They weather and then erode limestone. So a picture of that is, for example, this is from the USGS. This is Carlsbad Caverns. And these different cave formations grew as a result of, or developed as a result of groundwater that had calcite in it. And that is a chemical that, chemical compound, and as that interacted with the chemicals in the rocks of the cave, of the limestone of the cave, it developed these really awesome caverns. Our next type of chemical weathering, now we're getting away from water, we'll get back to the idea of living organisms that can cause weathering because they dilute acids, which weaken the rock. Dilute is kind of like water down. So you're watering down the acids and chemicals in a rock, and just weaken it so that it's more likely to be weathered by other forces. So if you're in, say, like a cavern or something, you're not supposed to be touching the features in the cavern, because that can cause those really awesome features to be more weak and susceptible to further weathering and erosion, and it can hurt the cavern. Or say like a worm, right? Our little worm friend can excrete as it goes through the ground. It excretes The liquids from its body dilute acids and whatnot in the rocks that it's touching, causing the weakening of rocks. The final type of chemical weathering is called oxidation. Oxidation, it has the word, it almost sounds like oxygen, and it has to do with oxygen interacting with iron in the soil. So oxygen in the air interacts with iron in the soil. And oxygen and air, sorry, not in the soil, in the rocks. Whoops. It can happen in soil too, or soil. And it causes rust. Think of like if you leave your bike out in the rain, you're gonna end up with that orange kind of rust color on your bike. That is what oxidation is. It's just oxygen interacting with iron. All right, so those are your final types of chemical weathering. So now we're going to talk briefly about differential weathering. Differential weathering is just talking about the speed of how fast different things weather. Differential weathering, it has almost the word different. Well, it does have the word different in it. So think everyone grows at a different rate. In the same way, rocks weather at different rates. So some rocks are more susceptible to weathering. If you have a really soft rock layer, it's going to be more susceptible to weathering. It's going to wear away faster than, say, harder rock underneath. Okay, so your soft rock wears away faster than your hard rock. So you're going to be left with, after the erosion of these soft rocks, that's going to weather and then erode away. You're going to be left with the hard, more weather-resistant rock underneath. Okay, so differential weathering, you just have rocks weathering at different rates. We talked about with that Devil's Tower in Wyoming, we said there are layers in the ground, right? And with the layers of different soil, inside of it at one point there was a magma chamber. So you got this really hard magma chamber that developed in the ground. And eventually, over time, that cooled and hardened into, so you started with a magma chamber, and it became igneous rock. Now, igneous rock is much harder than sedimentary rock. All around it is sedimentary rock. Okay? So over millions of years, you had the erosion, weathering and erosion of the sedimentary rock. And we begin to be able to see Devil's Tower. But see, as I'm getting to weathering the sedimentary rock around Devil's Tower itself is not eroding because it's a really hard rock. So it seems like Devil's Tower is rising up higher and higher from the ground. It's actually not rising, it's just that the rock around it is eroding, weathering and eroding away. Okay, so you're left with what we call a Devil's Tower. This massive igneous rock sticking out of the ground. Okay, we talked about the surface area of rocks. You could have one really big rock, and let's draw it three-dimensional. The areas exposed are susceptible to weathering. What's inside is not susceptible to weathering, but the whole outside is susceptible to weathering. But say that rock breaks in two. I now have a greater portion of outside area. So it's the same amount of space, it's the same volume or space, but it's a different amount of surface area. The surface area here, it gets greater. Whoops. Let's draw that as it's less than the surface area here. Okay, we now have a greater outside area. Because see, now this inside in between the two rocks is showing. That was not before. So my surface area has increased. So the more I break down a rock, the greater the surface area. And so it's actually going to weather and erode faster. So a lot of little rocks will weather much faster than one great big rock, just because you have more area showing. All right, then climate. Climate affects how fast things weather. Climate is the average weather in a given location. So that's like, what's the temperature, how much rain did they get, over a really long period of time. So you're not just looking at a single year, but you're looking at years and years and years in order to get what the climate of an area is. So greater the greater the temperature, so the hotter it is, temperature, then the more chemical reactions are going to happen. So you're going to have more chemical reactions. You're going to have greater amounts of chemical weathering in a really hot place. If you're in a place that gets really hot during the day, and then cold or freezing at night, that can lead to ice wedging. Right, that physical, mechanical weathering process. Because during the day, the water's going to melt, and then at night, the freezing causes the water to expand. So if you have this freezing and thawing cycle happening every day, you're going to have more ice wedging. If you're in a really wet place, you have a greater chance of oxidation. Oxidation happens in the place of water, so rusting, as well as some other chemical reactions, like chemicals getting in the groundwater and causing caverns to be formed. So the more water you have in a place, the greater chance of a chemical reaction happening. Okay, some other factors that might affect how fast something weathers would be elevation, if you are on a really high elevation, like up on a mountaintop, or if you're on the coast where the sea is. Right, so you're at the ocean. You might have, so sea level. You could have greater extremes of temperature And then you can have rocks being weathered by the ocean. I'll show you a picture of what that looks like. Right on the edge of a seashore, you can have like little rocks that are, they might have started as big rocks, but as the waves crash against them continually and carry them in the waves and they're rubbing against one another, those rocks break down into smaller pieces, and that's eventually how you're going to get the development of sand is this breakdown of little sediments. Okay, and then up on a high elevation, so much above sea level, you have greater temperature changes. There's greater temperature changes as well as winds. And winds can act as an abrasive force. So you're going to get more weathering up on top of the mountain or on the coast next to the ocean. You can also have, remember, slope of a mountain. You have gravity acting as a force that can push, cause rocks to tumble, and the greater speed that water moves down a hill, then the greater energy that's breaking the rocks. So as water slides down this hill, if it's like a creek going down a slope, or if it's rain rushing down a hill, you're going to have, by the end of this hill, that's a lot of force coming at the rocks, acting as a weathering force. All right, so enough about rocks. Let's get to soil. Soil is just a loose mixture of small mineral pieces, organic material, water, and air. So you have minerals, organic material, which we talked a lot about, as the breakdown of dead plants or animals. There's water in it, and then there's air. All those things make up soil. Soil is made from weathered rocks. So you have those loose mineral pieces. Those would be from weathered rocks. And the rock that it comes from is called the parent rock. And so chemically different rocks are going to yield chemically different soils. So different types of soil have different chemical makeups. Underneath soil is bedrock. So you have soil, and then you have bedrock underneath it. And if the soil stays in the same location as if it matches the bedrock, right, it came from the bedrock, then it's called residual soil. It resides in the same place it was formed. If, however, it moves away, if the soil moves away from the bedrock that formed it, right, it moved, that is called transported soil. So it's no longer going to chemically match the bedrock that it's laying on top of. Okay? So soil has several different properties. We talk about soil composition. Composition has to do with the way something is made up. So soil composition, it's just what are the different materials that are making it up. Or composing it. And that affects the kinds of plants that are going to grow there. So different types of plants prefer different types of soil. And then how much also. is the question. How much of each different kind of material is there? In different places, some places will have a lot of, if we were to draw like a circle pie chart, some places will have a lot of organic material. Whoops. Whereas different type of soil might have much more, say 3%, and this one say 15% organic material. So the question is, they might both have organic material, but the composition we'll be talking about, okay, which one has how much of each different kind of material. There's also soil texture. These are just words to describe soil. Soil texture is the different, or the amounts of different size particles in a soil. Because soil is made up of several different things, water, air, minerals that are broken down, you have weathered pieces of rock. The question is, how much of the different size pieces, the size particles, are there? And that affects the consistency of the soil and how easily water moves through the soil. So often you talk about that there's clay, silt, and sand. And those are different textures, they have different amounts of different size particles. And so you basically have this triangle, and the perfectly balanced soil would have an equal amount of all three, right? But so you have clay, silt, and sand. But some soils are more towards the sandy spectrum. Some are more clay, some are more silt. So the question is just, where do we fall on this spectrum? Where do we fall on this triangle? The next property of soil is soil fertility. That's asking how well will things grow there. Will plants grow? So how much nutrients does the soil have? Whoops. Plants need nutrients to grow. Without nutrients, the plants are not going to be healthy. They're not going to be able to produce very many of their own fruits, and so they need that nutrients. So if a soil is not very fertile, that means that it does not have very much nutrients. The nutrients are coming from the parent rock, where rocks are composed of minerals and chemicals, or from humus, which we talked about. Humus is that organic material that is broken down. So you have decomposing organic material that becomes humus. Humus is really good for the soil. You don't want too much of it, but it does provide nutrients to the soil and to the plants. So then we could talk about the layers of soil. Those are called horizons. Think like the horizon of the setting sun, right? You have the setting sun behind the horizon. So it's just a horizontal layer. So you have, first of all, the O horizon. That's your organic material. O for organic. Not all places are going to have very much organic material. So you're going to get different amounts of that. So some places won't even have that layer. Then you have your A layer. That's your topsoil. that is nutrient rich. It's what the plant's roots are going to be in, reaching down to. If you've stripped your topsoil, you're kind of in trouble. It contains a lot of the humus that trickles down from the organic material. Okay, again, so that means it contains the nutrients. Underneath your A topsoil layer, you have E horizon, which again, not all places are going to have E horizon. In the E horizon, it has very few nutrients. You don't have a whole lot of nutrients trickling down from your O horizon into the E horizon. Most of those are in the topsoil. And as water moves through the soil, right, as water goes down through the soil, it's taking nutrients with it, and it's going to collect down at the bottom. So it's leaching, remember the word leaching, it's leaching the nutrients from the soil. Underneath your E horizon, you have the B horizon. Your B horizon is really nutrient rich because all those nutrients that are being leached from the E horizon, that have trickled down through the E horizon, are caught in the B horizon. So you have lots of nutrients here. Underneath your B horizon, you have the C horizon, which is weathered bedrock. Weathered bedrock means you've got some rocks, but you also have some of those nutrient pieces. You have some soil mixed in there. It's just broken up bedrock. And then you have your final horizon, which is just the R horizon. That stands for the bedrock. Okay, so that's your solid bed of rocks. It hasn't been weathered much. Above that, in the sea horizon, it is weathered. But so your main soil layers, think of A, B, C, and then interjected with that you have O in case you have organic material, you have E if a lot of the nutrients have been leached out, and you have R underneath it as your bedrock. So R for rock. We talked a little bit about pH of the soil, just the different soils have different acidity, which depends on like fertilizer and rainwater. But we talked more about climate change and climate and soil.